So we have been discussing multiple inheritance. We'll discuss one more case of multiple inheritance, which is the diamond. So what is the diamond? Well, it's a structure which of inheritance which looks like the following. So B derives from A and B derives from C, and then D derives from both B and C. So what should be what does this mean, and what should be the semantics? Well, so first of all, in C++, this is the code that you would need to write to construct such a diamond structure. Example, you declare a class A, which has a field X and a virtual function VA. Then you would declare a class B, which derives from A and has Y and VB, and class C that also derives from A and has Z and VC. And then class D, which derives from both B and C. This is multiple inheritance. And then it has a field W and a virtual function VD. The question is, what should be firstly, what should be the meaning of such a derivation? So actually there are two cases here. One is there should be multiple copies of A, which means D would have multiple copies of the state of A. So for example, multiple copies of X. And the other case is that there would be a single copy of A. And the way that would be done in C++ is through this virtual keyword. Here this means that B derives from A, but A is a virtual base class as opposed to a non-virtual base class. So what does a virtual base class mean? Well, it just means that, if there is multiple inheritance, then there would be only a single class A. So think of virtual base class as a level of indirection. So it's a pointer to a base class, right? And so if there are multiple virtual base classes, you just have multiple copies of the pointers, but the original base object remains a single object. So there remains a single copy of A. So let's first consider the case of multiple copies of A. The basic principles remain the same. So for example, this is the object D that first has the object B that contains A inside it. So this is object B, this is object of class B, and then an object of class C, which is this X and Z. Notice that X has been repeated twice, so there are multiple copies of A. And then there is the V table, this should be C, and then there are multiple, and then there is the V table for D, just like we had earlier, right? So this is just what nothing changes between multiple inheritance as we discussed in the previous module and multiple inheritance with the diamond structure. Just that there are two copies of X, and depending on what context it has been used in, the appropriate copy would get used. Right now, which copy gets used, that's a programming language semantics issue. We are discussing code generation, but based on the semantics, I know whether it should be X or whether it should be this X or this X, and based on that, I would be able to do that. All right. Typically, the programming language would require the programmer to disambiguate which X it is he or she is talking about. All right. Similarly, on the V table side, everything looks the same. So this is the V table part of B, right? And then this is the V table part of C. Notice that the top offset here is -12 because that's the offset from the V table pointer, the place where the V table pointer has been stored, to the top of the object, right? So that's -12 in this case, because there are 3 fields before this V table comes, and recall that the top offset is required to do pointer readjustment and things like that in case of multiple inheritance. And then you have the V table fields for D itself. Okay, so nothing much has changed actually for multiple copies of A. Let's look at the other case, which is the single copy of A. So first thing to note here in the single copy of A is that the classes B and C also know that their base class is actually a virtual base class, right? So they know that it's not like the virtual base class is encapsulated, the fields of the virtual base class are encapsulated in the fields in the object B. It's more like I have a pointer to the place where object A lives, right? So this is how it's going to look like. This is the object T, this part is the object of class B. This part is the object of class C. This part is the remaining fields of D, and then this part is the object of class A. Now you may say, okay, but what now if I was to executing this using this in the context of B, then B doesn't contain A, and so isn't that a problem, because B is supposed to be a derived class of A, and based on our single inheritance principle, A's fields should have been laid out before B's fields. But that's the difference between a virtual base class and a non-virtual base class. So our previous code generation strategy, where the fields of the base class were laid out before the fields of the derived class, was for a non-virtual base class. In the case of a virtual base class, through the V table, in the V table, I will store a pointer to the base class. So I'll need to have a pointer here, and this would be the base class object pointer, something like that. All right. And so this is going to come from the V table. So it's not as V table is going to point to a structure that's going to point to this. All right. So we're going to see that in more detail. And so here is what it looks like. V table for this was object B. So this is object B. So V table for B looks like the following. It has the virtual function for VB. It has a type info as always. It has the top offset, which is 0 in this case, because that's the distance between the top of the object and the VTable pointer, the place where the VTable pointer has been stored. And then there is another field now, that's the VBase field, and this is used for classes that are derived from virtual base classes. And VBase is basically pointing to the virtual base object. All right. And so in this case, I'm storing an offset which says at what offset from the top is my base object present, and the answer here is 24, because the offset here, this one from the top, is 24, because there are 6 fields in the middle, 1, 2, 3, 4, 5, 6, and so this is offset number 24. So that's the way. And so even the code for B, in the context of B, is going to first look at the VBase, add that, and then use the VTable and the fields to access elements of A. And so that's just because A is a virtual base class and not a non-virtual base class. All right. So that's I guess that basically explains how things are going to work with the virtual base class. Similarly, the same thing, identical thing for C. So C is this object here is C, and this is what this is also part of the C's VTable, and in this case virtual base is at offset 16 in this particular case, right? And so that's the code in the context of C is going to dereference this value, identify that it's 16, add 16 to the top to get to the VTable. So the offset is from the VTable of the object itself. So in this case, that's where it's going to be B in the context of C in any case, because of pointer adjustment, and so it's at an offset of 16, and that's where it should look for X. All right. And so the rest of the fields are exactly as you would imagine. These are the remaining fields of D, and once again this is top pointer, but here I don't need a VBase pointer because D doesn't have a virtual base class. And then these are the fields for A.